We are going to practice simplifying exponents, more specifically exponents that are negative. Um, in math, you never want to have a negative exponent left in an answer. It's not properly simplified at that point in time. So the first, I have three problems up here. The first two, you have to understand that going back to what a term is in math, where a term is separated by is not separated by multiplying or dividing, but is separated by adding or subtracting. The two problems that I have initially in the top part of this, they are both one-termed expressions. There is no adding or subtracting in that at all. And when there is no adding or subtracting, we have the ability to simply to take care of the negative exponent by just moving it to the other side of the fraction. It gets a little harder when we have more than one term. But to start off, I see a set of parentheses there with an exponent outside. So before I start moving things around, I would probably go and take everything to the negative third power. So x to the third times negative 3 would be negative 9. Y, I have a negative 1 times the negative 3 is going to be positive 3 over z to the negative 6. Now, I'm going to look at it in terms of which variables have a negative exponent. Since there is only one term in this problem, I can simplify this by just moving them to the other side of the fraction. So I'm only going to move what has a negative exponent to it. So y to the third is going to stay in the numerator. Z to the 6 is going to move up to the numerator, and x to the 9th is going to move down. And z and x will now no longer have a negative exponent to it. Okay, moving on to another problem. I'm going to highlight for you so you can see which which variables have a negative exponent to it. At this point in time, I'm going to just move those two that I highlighted to the other side of the fraction than what they are on. When I do that with my a's, I already have, well, I have a to the second on the top, b to the third is not going to change, and the 3 is not going to change. So the a's are going to move up to the top, so now there's going to be 6 of them, and another 6 up top, and b to the fourth is going to move to the bottom. And we do want to simplify this because we don't want to have like two a's not combined. So a to the second times a to the 6th is a to the 8th. And we're going to have 4 plus 3 b to the 7th in the denominator. Okay. It does get harder when we have exponents. See, we have negative exponents, and we also have more than one term. So on a problem like this, it's a little bit harder. We are going to have to kind of look at what each term is individually. So to start here, I really have in this first 6a b to the negative second. It's the same thing as 6a and then b to the second. So I'm actually going to represent each term in this fraction. I'm going to make the fraction within the fraction so I can see what's going on. So in the second one, term in the numerator, the a to this negative second needs to move to the denominator. So I end up having 3b over a to the second. And I'm going to end up having 9a over b to the third minus 12b squared over a to the third. And as you can see, now we have fractions within fractions, and that's what we're going to need to get rid of. You're going to look for the common denominator, the expression that is what all denominators can go into. I see that the highest exponent on b is 3, and the highest exponent on a is also 3. So our common denominator in this case is going to be a to the third b to the third. And to get rid of the fractions within fractions, we are going to multiply every term in this larger fraction by that common denominator, a to the third, b to the third. And I'm going to try to do this color-coded so you can see what's going on. The hope is that, or the purpose of that was that we can cancel and simplify all of our denominators of our fractions within the fractions. So if I look at this first part, I have b to the third over b squared. So the b's will cross off, leaving just one b left over. When that happens, I'm going to now have 6a times b times a to the third. So it ends up being 6a to the fourth b. And we're going to do that with every single term. So we're going to move over here to the other term in the numerator. And in this case, I'm going to have two of the a pairings cross off. So I'm going to end up with 3b to the fourth a. Moving to the denominator, all of the b to the thirds cross off, so I end up with 9a to the fourth. And all of the a to the thirds cross off, so I have, oops, this isn't an adding, this is subtracting. Subtract 12b to the fifth. Now the one thing that I'm going to look at is coefficients. I haven't talked about them yet. 6, 3, 9, and 12 all have a factor of 3 that I can factor out. So I'm going to do that. Factor out of the numerator, factor out of the denominator. And since I factor them out, they both cross off, and our final answer would be 2a to the fourth b plus b to the fourth a over 3a to the fourth minus 4b to the fifth. So it's definitely a little bit harder when you have a fraction and negative exponents in something that has more than one term to it.